In this video, we're going to consider derivatives and integrals for trigonometric functions. In particular, trigonometric functions in this form, which often cause confusion for students. But the key is, let's say you had a trigonometric function in this more basic form, like sine 4x or cos 2x, so sine or cos number x. Well, how do we differentiate or integrate that? Well, we use the chain rule, don't we? Because this is a composite function. The function 4x is inside the sine function. Or if this is on a formula sheet that you get as part of your course, then that is just going to be a direct, pull off the formula sheet. So we would differentiate this by saying, okay, well, when you differentiate the sine function, that goes to cosine, positive cosine. So it'll be like this. So cosine of 4x. A good tip is that the part in the bracket for all of these never changes. Okay, so never try and change it inside of the bracket. But because this is the chain rule, that's our first derivative, and our second derivative, if you like, is the derivative of the inside of the bracket. That's always how the chain rule works. So it's going to be this multiplied by 4. But most students don't even write that, and you don't have to write that. They can just look at that or refer to a formula sheet and realize that the answer is going to be 4 cos 4x. They sometimes forget that this 4 is a derivative of 4x, but the key thing that we're focused on here is that the number that we multiply in front is the derivative of the inside of the bracket. Now that's the key for when you get to these more difficult scenarios, because most students are okay with this scenario, derivatives or integrals of something that look like that. And by the way, the integral case would be if we were integrating sine 4x. Again, very similar process, but instead of multiplying by the derivative, we also use the derivative, but we divide by it. So sine integrates to negative cosine, so this would be negative cosine 4x, and then we're dividing by the 4, and we usually just write that as a 1 over 4 in the front, and because it's an indefinite integral, we need a plus c on the end. So when we come to this case here for the derivative, or this case for the integral, in both cases like this one over here, we're still using the derivative of the inside of the bracket. So in this case here, let's start by considering the derivative of this. Well, 3x minus pi over 7 looks a lot more complicated than just 4x. But what is pi over 7? It's just a number, right? So if you differentiate 3x minus some number, you just get 3. Because when you differentiate a number, even if it's a fancy number and it's got a pi in it, it still goes to 0. So the derivative here is still just 3. So when we take the derivative of that overall function, it's actually not that dissimilar to what we did here. So we can say, right, when you differentiate cosine, that goes to negative sine. The 2 is just going to stay as a 2. So it's going to be negative 2 sine. The bracket, like I said earlier, never changes. So we leave the bracket. And then we're just going to multiply that by whatever the derivative of that is, which is just the number 3. So nothing fancy, very similar to this case. We can then tidy this up by multiplying those together, or if you're confident, you can go straight to this final form from here. Minus 2 times 3 is negative 6. So it's negative 6 sine, and then again, the bracket never changes. Okay, so this case, it looks a lot different to this one, but it's actually very similar in how it works. Let's take a quick look at the integral. Same idea, just that we're dividing by the derivative. It's the same function actually, so the bracket again never changes. When you integrate cosine, that goes to positive sine. The 2 is just going to stay there, so it's going to be 2 sine, and then the bracket will stay the same. 3x minus pi over 7. This time we're dividing by the derivative. The derivative is still 3, so we would divide by 3, or you could just write it as 2 over 3 like that. Because it's an integral, an indefinite integral, we're going to put our plus c in the end. So in all of these cases, which are all examples of the chain rule, we're just using the derivative of the inside of the bracket. If there's a pi over something, plus or minus pi over something, that doesn't play any part in the derivative, it's just a number. So it's only this number here that you're going to be multiplying or dividing by.